We're going to be right on the next page here. And we're going to still talk about proofs, but they're going to look just a little different than yesterday because of how they're giving us the given and the proof statement. So yesterday you were given like an angle pair, and it would say, hey, these ones are congruent or these ones are supplementary. And then we would work within that information about how do we make like a pathway. So you were kind of told like you have these angle pairs and you're trying to, you have like these parallel lines and you're trying to show that these angle pairs are equal to each other. Today it's a little bit different. They're going to switch it on us where they're going to give us an angle pair and we're trying to prove that lines are congruent to each other. To do that, we need to talk about this converse at the very top of your page here. Oops. So I'm talking about this thing right here, corresponding angles converse. What that says is that if you have two lines that are cut by a transversal and the corresponding angles are congruent to each other, if you know that, then we know that the lines in the picture are going to be parallel to each other. Converse in geometry means the opposite. So originally we would have said things like, you have parallel lines. That means corresponding angles exist. And they're congruent because they're on parallel lines. The converse says, take that statement and read it almost backwards. So you know you have corresponding angles that are congruent. That must mean that there's parallel lines somewhere in the picture. That's what the corresponding converse says. So today we're going to use this in order to help us show that lines in a picture are parallel. So we're going to start out with an angle pair. And again, they might be corresponding, they may not be. We can't use corresponding as like a reason for angle pairs, but we have to get to corresponding angles in order to use the converse. So I'm going to show you a couple of how these work, and then just like yesterday, you'll have one here in your notes. The last one there will be for you guys to do as homework. Okay, so take a look at what they have here, and they were nice and they gave us all the statements, so we just have to figure out what the reasons are. So they're giving us the fact that angle 2 is congruent to angle 7. What do we always put down for our first reason, guys? Given. So we know, according to this problem, that angle 2 and angle 7 are congruent. That means that they're equal to each other. They have the same measure. Okay. Now going to step number 2, they then go on to say angle 7 is congruent to angle 6. Why can we say that? They're what? They're vertical. Okay, now because I'm trying to show that lines are parallel, that means I'm trying to get to corresponding angles. So now if you look at the next statement, it says angle 2 is congruent to angle 6. Are 2 and 6 corresponding? Yeah, they're a corresponding angle pair, okay? But remember, we can't use like corresponding angles as a reason because eventually we're going to have to use that corresponding converse. So I need to figure out a different way to justify this claim. So let's go back and look at what we had written before. Step 1 said angle 2 was congruent to angle 7. Step 2 said angle 7 was congruent to 6. They then wrote that angle 2 was congruent to 6. What'd they do there, Parker? You're really close. It's not transversal, but it's really close to that. Macy? Transitive, right? Transitive property. We talked about that yesterday. Remember I picked on a couple up here talking about how they all had dogs? So because they share that 7 here and here, they're skipping over that in order to make the connection between 2 and 6 because they recognize 2 is equal to 7, 6 is also equal to 7, so we can cross off 7 and go straight from 2 to 6. And that's using our transitive property there. Now to finish this, because we're at corresponding angles now, 2 and 6 are corresponding to each other, and we were able to show that they're congruent, that means we can use our corresponding converse because we have corresponding angles already stated. So once you have your corresponding angles stated, guys, and you're trying to get to your last step, which is to show that those lines are parallel, you just need to use that converse that we talked about at the top of the page. So I'm going to write here is corresponding converse. I know I said earlier, like, you can't use corresponding angles as a reason, and it might feel like that's what I'm doing on step 4 there, but I'm not using corresponding angles as my justification for why the angles are equal. I'm using that to show I ended at a pair of corresponding angles. That means that my lines are parallel. So it is different than saying corresponding angles are equal to each other. I didn't say that at all during my proof. So for all of these, because we've only talked about the corresponding angles converse, that's kind of where you want to lead yourself to when you're doing these proofs. So whether you start with, like we started out with 2 and 7, those are actually alternate exterior angles. We then made a pathway to get to corresponding angles. So we're going to continue to do that for all of these. No matter what you start with, your end goal is to try to get to those corresponding angles.
Haley.
Okay, thank you.
Thank you.
Okay, so let's take a look at the next one. And remember, what I just said there is we're ultimately trying to get to corresponding angles so that we can finish this proof with that converse. But you may not start out with angles that are congruent. Like that one we did, but if you guys look at the next one, what are they giving to you originally? What's the given statement say? Okay, 4 and 6 are supplementary. They're not saying that they're congruent this time. So we're going to have to do a little bit more work because we're starting out with supplementary angles. We're going to have to get to those corresponding angles that are congruent. We'll have to kind of work our way there. So reason number 1 is what? Given. Okay, 4 and 6 are supplementary. That's statement 1. Statement 2 says angle 4 plus angle 6 equals 180. How come we can say that?
The same side interior.
They're same side interior. That's true. What does supplementary mean?
Add to 180.
They add to 180. So we're just using the definition of supplementary there. Because they're saying these angles are supplementary, that would then tell us, okay, that means they should add to 180. So I'm just going to go ahead and write for number 2, definition of supplementary. Okay, how about for number 3? 3, they say angle 8 plus angle 6 is 180. Why? They're a linear pair. Okay, remember that I'm working towards getting to corresponding angles in order to help me out here. So I started out with 4 and 6, and I'm now making a connection to 6 and 8. Because if you guys look at 4 and 8 on the picture, would angles 4 and 8 be corresponding to each other? Yeah, so they're kind of trying to lead you to some pair of corresponding angles. Now, they chose 4 and 8 for this problem, but there are other corresponding angle pairs that they could have gone with. They could have tried to connect 6 to angle number 2 if they wanted. They just already had the statements filled out for me, so I'm just kind of following their lead here. But so they're trying to make this connection between 4 and 8, so we're just trying to kind of follow what they're doing. So far we've said that 4 and 6 add to 180. Then they made a connection from 6 to 8, saying that they're also going to add to 180 because of a linear pair. Now, eventually what I'm trying to do here is get from 4 to 6. I'm sorry, 4 to 8, so that I can say that I can use my corresponding converse. So I'm not quite there, but I'm close. Because if you look at number 4 now, what did they do? Keegan?
Transitive.
Transitive? Why do you say that?
Because they're the same to each other. Like,
Okay. What did they skip over?
I don't know.
What did they cut out of the problem?
Oh, the 4. Or wait. I don't know.
Don't skip ahead to 5 yet. I'm still on 4. What did they skip over from steps 2 and 3 to get to step 4? The 180. So instead of saying that they're both equal to 180 separately, because we know that they're both equal to 180, we can say this piece is equal to this piece. Now we're skipping over that thing in the middle. Okay, it's like the same idea as yesterday when we talked about these 3 having dogs and how I can connect the first and the last by skipping over the person in the middle. They're skipping over the 180. The 180 is like in the middle right now. So we're going to go ahead and say transitive here. I'll also say you could have said substitution. Because sometimes kids will say, instead of saying equals 180, I'm going to replace 180 with those other two angles, 4 or 8 and 6 together, because it's like that idea of, yes, we talked about like when you're playing football and we want to replace you if you get hurt, they're not going to throw in a different position for that person who gets out. They're going to put in the same player, the same type of player. So we could have also argued substitution here. So I will write that down just in case you were thinking maybe substitution would have applied. Where you're just replacing that 180 with 8 and 6 instead of skipping it over. Either one would be acceptable there. Okay, what did we do from 4 to 5? What's different? There's no angle 6 anymore. How'd they get rid of it? Transitive would work again because they notice that 6 is shared, so we could skip it over. Maybe some of you think about this algebraically, though. Is there an operation we could perform to get rid of 6? Subtraction would work too. So again, I would take either reason here. So if you say transitive, that's okay. If you think about subtracting angle 6 though, because you see those plus signs and you see an equal sign there, maybe you think about solving an equation, you could use subtraction to get rid of angle 6. Okay, how'd we go from 5 to 6? Keegan?
Definition of congruence or whatever.
Yep. We just switched from equal to congruent. Okay, 4 and 8 are congruent to each other. What kind of angle pair did we say 4 and 8 were going to be? Corresponding. So since we're at corresponding angles now, and we know that they're congruent to each other, that means we can use our corresponding converse to finish this, because we're trying to show that those lines are parallel. So last step is to say corresponding converse. Both of those problems were a little different in just what they started us out with for our given information, and then how we had to work to our corresponding angles. The first one was a lot easier to get there because we had already started out with a pair of congruent angles. So we didn't have to do as much work to make the pathway. The second one we had to do a little bit more work on because we started out with supplementary angles. Well, supplementary doesn't help us with corresponding. We had to then change supplementary to congruent. So it took us a little bit longer to get there. But notice how both of those end with the corresponding converse. When you're doing these proofs where you end with lines that are parallel, you're always going to end with the corresponding converse. So on a proof like this, if you recognize that you're trying to prove lines are parallel, you should be able to fill out the given, and you should be able to fill out the last statement because you're going to end with that corresponding converse. That's different than what we talked about yesterday, because yesterday we weren't proving lines were parallel. We were proving that angles were congruent to each other. And so we could have maybe went about it differently, and you might have had different ending reasons. All right, at the bottom of this page, there's this problem. This is what you're going to do for homework today, along with another worksheet that I'm going to give you guys, okay? So I'm going to pass out the worksheet and explain what that looks like.